60. So Tom is now clearly 25, so 50 plus 10 is 60, and so Tom will be 25 plus 10, 35. So Tom is now 35, his mother is 60. So the ratio of their ages is 35:60. So we could solve it. Using both the statements together, we could solve it. So we pick option 3. Question 40. What is the length of the sides of the square? Statement A. Area of the largest circle that can be inscribed in the square is 154 square centimeters. Statement B. The diagonal of the square is longer than the length of the sides by 3 centimeters. Using statement A alone, from area of the circle, we can find the diameter of the circle, which is equal to the length of the sides of the square. From the area of the circle, largest circle that can be inscribed in the square. So the radius of the circle is half of the length of the side of the square. So from the area of the circle, so that is pi r square, right? So using the formula, phi r square is 154. So we can solve for r. We know the radius of the circle. And the radius of this circle, largest circle inside the square, is nothing but half of the length of the side of the square. So we can find out the length of the square. So this statement alone is clearly sufficient. So we're using statement B alone. The sides of the square, the diagonal of the square is longer than the length of the sides by 3 centimeters. So there's the square and the diagonal is greater than the length of the side by 3 centimeters. So we know the ratio between the diagonal of a square and the side of the square, right? Diagonal is square root of 2 times the side of a square, right? Because x square plus x square equals diagonal square. So 2x square equals diagonal square, and so diagonal is square root of 2 times the side of the square. So diagonal is approximately 1.41 times the length of the side of the square. So and we also know that, you know, if you square them, so so basically it's like square root of 2 times x minus x equal to 3. So that's what it means. And if you can solve, square it, okay? So diagonal is greater than the side by 3, right? So x plus 3, the whole square, is nothing but 2x squared. Just square it because it's easier to solve. And solve this equation, okay? So solve the quadratic equation to find x. So I'm saying either way, this using B alone, we can solve for the value of the length of the side of the square. So either statement alone is sufficient. So we pick option 2. Question 41. Who is the youngest among John, Peter and Tom? When Peter was 6 years old, Tom was 3 years older than the average age of Peter and John. So 3 guys, John, Peter and Tom. When Peter was 6 years old, Tom was 3 years older than the average age of Peter and John. So looking at the statement, don't be inclined to think that Tom was older than Peter. We don't know. Let's say the average age of Peter and John was, you know, like 3 years, or, you know, less than that. We can't have less than that, because even if John was 0 years old, the average would still be 6, and Tom would be 3 years older, and he would be at least 6 years old. Yeah, anyway, we'll analyze it later. So we have the statement, and then statement B. John's age is equal to the average of the 3 friends' ages. So using statement A alone, we don't know if John is older than Peter. If John was minimum 1 year old, so what is the minimum age that John can have? 1 year old, right? I mean, generally there's nothing like 0 years old. So if John was minimum 1 year old, so Peter was 6 and John is 1. So average of Peter and John would still be 6 plus 1 divided by 2. That is 3.5. Tom was 3 years older than the average of Peter and John. So if the average was minimum 3.5, Tom was 3 years older. So he would be 3 years older than 3.5. So Tom would be at least 6.5. So Tom will be anyway older than Peter. Okay? So Tom is older than Peter. So Tom is clearly not the youngest. So between Peter and John, we have to find out who is the youngest. So if John is older than Peter, we consider a situation where John is like the minimum age. If John is older than Peter, then the average would be greater than 6, right? 6 and say 7. So their average would be greater than 6. And Tom is older than 3. So either way, Tom is older than Peter. But John may be younger than Peter, or John may be older than Peter. We don't know that. So a John or Peter, either of them could be the youngest. So statement A alone is clearly not sufficient. Using statement B alone, we cannot. So John's age is equal to the average of the 3 friends' ages. John's age is equal to the average of the 3 friends' ages. So we cannot infer who is youngest. So John's age is equal to the average of the 3 friends' ages. So it's possible that all 3 of them are of the same age, or it's possible that Tom is older, Peter is younger, or Peter is older, Tom is younger. Either of them is possible. So we still can't infer. So either statement alone is not enough. But using both together, so John is equal to the average of the 3 friends' ages, right? So substitute John's age as, say, John plus Peter plus Tom divided by 3. Okay? That's John's age. So when Peter was 6 years old, how old was John? John was Peter plus John plus Tom divided by 3. So 6 plus 6 plus j plus t divided by 3, and you take the, so when you're calculating the average age of Peter and John, substitute John's age as the average of the 3 friends' ages, and then you take the average of that, and when you find that particular value, it will be in terms of Peter's age, and using that you can say Tom is still older than Peter, and using that particular equation we can determine that Peter will be the youngest. Response question. So basically the average of the 3 friends' ages, right? So we know using both these statements that Tom is older. So John is the average of the 3 friends' ages. So Tom is older. So if Peter and John were the same age, then the average of the 3 cannot be John's age, right? The only way you can have John's age as the average of the 3 friends' ages is when Tom is older and Peter is younger. Only then John can be in between. He can be the average, right? They're not all 3 of the same age. One is older. So only when the other one is younger, John can be in the middle, right? Average. So using both together, we can say Peter is the youngest. So both the statements together, we can say, so we pick option 3. So question 42. What is the length of the edges of the cube X? So statement A, the surface area of a cube Y, whose volume is 3 times the volume of this cube, is 250 cubic meters. Statement B, the diagonal of the cube X is 24 meters. So using statement A alone, surface area of a cube Y is, let's say it has a side Y, so it will be 6y square. 6y square, whose volume is 3 times the volume of this cube, is 250 square meters. Sorry, it's not cubic meters, square meters. So we're talking about surface area, okay? Surface area is 250 square meters. That's what it says, okay? So, so 6 times y square is 250. So from that we solve for y, which is the edge of the length of the edge of the bigger cube y. And we know that the volume of this cube is 3 times the volume of the smaller cube x. So we know the edge of the bigger cube y, and from that you calculate the volume, and that is 3 times the volume of the smaller cube. So from that we know the volume of the smaller cube, and from that you take the cube root of that, we know the length of the edge of the smaller cube, right? So we solved for, using statement A alone, we can calculate the edge of the cube x. So using statement B alone, the diagonal of the cube x is 24 meters. So the diagonal of a cube, what is it? So say x squared plus x squared plus x squared, that's 3x squared, and you take the cube root of the square root of that. So it's square root of 3 times x. So that is 24 meters. So directly you can calculate x. So either statement alone is sufficient. So we pick option 2. Question 43. In how many days will 3 women complete the work? Statement A. 4 men can complete the work in half the time taken by 12 women to do the same work. Statement B. 2 men complete half the work in 7 days. So using statement A alone, we can determine 1 man is equivalent to how many women? 4 men can complete the work in half the time taken by 12 women. So clearly 2 men can complete the same work in the same time taken by 12 women, right? So, or for using this statement, you get a relationship between the number of men and women, the time taken to do the work, ratio of how much time a man takes to how much time the women takes. So half the time taken by 12 women is nothing but the time taken by 6 women, right? So 4 men do the same work as 6 women. So 2 men do the same work as 3 women. Okay, so we got that relationship straight away. Or 1 man can do the work, same work as in, takes the same time as like 3 by 2. For doing the same amount of work, you can either use 1 man or 3 by 2 women. So that's what it means. And but it's not enough to say how many days will 3 women, in how many days 3 women will complete the work. Using statement B alone, so 2 men complete half the work in 7 days. So we clearly know that 1 man can complete the work in 14 days. So from this we know exactly how much time 1 man takes to complete the work. So in this statement A, we just know the ratio of time taken between men and women, but we don't know how many days they take to complete the work. But in the statement B, we know exactly how much time 1 man takes to complete the work. So using both the statements together, we can say how much time 1 woman will take to do the work, and from that we can calculate how much time 3 women will take to do the same work. So we pick option 3. Both the statements are required to solve the problem. You don't have to sit and calculate the numbers and find the exact answer. All you have to say is if both the statements are required or either statement alone is enough. So question 44. What is the acceleration of the car? Statement A. The car covers 20 kilometers in 30 minutes. Statement B. The car speed increased uniformly by 3 kilometers per hour every minute. So using statement A alone, we can only know the average speed of the car. 20 kilometers in 30 minutes. So that's like 40 kilometers in 1 hour. So the average speed of the car is 40 kilometers per hour. That's all we can infer from statement A. We don't know the acceleration. It might have gone faster, slow, faster, slow. I mean, we don't know. And we don't know if even if it was, say, uniform acceleration, we just know the average speed of the car, okay? It might have gone faster and slow, faster, slow. We don't know, right? Because it doesn't say uniform. And using statement B, the car speed increased uniformly by 3 kilometers per hour every minute. So clearly the acceleration is directly given here as 3 kilometers per hour. So it's like 3 kilometers per 60 minutes. And divided by every minute. So speed divided by time is acceleration. So directly it gives you here. So statement B alone is sufficient. Pick option 1. But statement A alone is not sufficient. Question 45. What is the total cost of 3 tables and 4 chairs together? Statement A alone. Cost of 2 tables and 3 chairs together is $150. Statement B alone. Cost of 5 tables and 4 chairs together is $280. Using statement A alone. So 3t plus 2t plus 3c equals 150. And using B, you can have multiple values for t and c. You can't get unique solution. But using B alone, 5t plus 4c is 280. So you can have multiple values here again. But using both the statements together, we get a unique value of number of cost of each table and cost of each chair. So both the statements together are sufficient. So we pick option 3. Question 46. Jack and Jill purchased foreign currency to travel to Thailand. How many Thai baht did they get? Statement A. The conversion rate on that day was $1 equals 32 Thai baht. So Thai baht is the currency of Thailand. So statement B. Jack converted $100 into Thai baht and Jill got 1600 Thai baht after conversion. So let's say using statement A alone, we know the conversion rate, but we don't know how much currency they converted into baht, right? But using statement B alone, Jack converted $100 into Thai baht and Jill got 1600 Thai baht. After she gave X amount of dollars, she got 1600 Thai baht. But we don't know the conversion rate. So using both together, we know how many dollars they converted and how many Thai baht they got. So we pick option 3. Question 47. An equilateral triangle is inscribed in a circle. So the circle and an equilateral triangle is inscribed inside the circle. What is the difference between the area of the circle and the equilateral triangle? So the circumference of the circle is 68 centimeters. Statement A. Statement B. The height of the equilateral triangle is 13 centimeters. So draw a picture for your own reference. So using A, the circumference of the circle is 68, so 2 pi r is this, and so you calculate the radius of the circle. From this we know the radius of the circle. So there is a circle and an equilateral triangle inside it. Okay, so what is the height of that equilateral triangle? So the radius of the circle is nothing but 2/3 of the height of the equilateral triangle. That's geometry, refresher geometry. So the radius, so you have like a circle here and a triangle inside it, and there's the height of the triangle. So you make a 2/3 part and then you draw lines like this, they'll be equidistant. So you'll have the radius is nothing but 2/3 of the height of the equilateral triangle. So from this we know the height of the triangle, and once you know the height of the triangle, equilateral triangle, you can determine the length of the side of the triangle, right? So it's an equilateral triangle and we know the height. So from that we know that the height bisects the base, right? So we have say half of the base here and then one of the edges here, which is double the half of the base, and then we know the height. So from that you just plug in the values and you'll be able to solve for the length of the side of the equilateral triangle. And from that you calculate the area of the equilateral triangle. So we know the area of the circle and we know the area of the equilateral triangle. You subtract them and you get the difference. So I'm saying it's possible to solve it using statement A alone. Don't waste your time plugging in values and solving it. Just think about, is it doable? Is it solvable using A alone or not? It's solvable. So that's all we need to know. And then using B, we calculate the side of the equilateral triangle and its area. The height of the equilateral triangle is 13 centimeters. So we know the height of the equilateral triangle, and 2/3 of the height of the, from that we can calculate the area of the equilateral triangle. And from the radius of the circle is nothing but 2/3 of the height of the equilateral triangle, 2/3 of 13. That's the radius of the circle. And so because the triangle, equilateral triangle, is inscribed in the circle. So we know the radius of the circle, we calculate the areas of the circle. So height of the equilateral triangle, so we calculate the radius and this thing. So we, using either statement alone, we can solve for the area of the circle and the area of the equilateral triangle, and we can get the difference. So either statement alone is sufficient. So we pick option 2. Question 48. So 3 trans X, Y, and Z distributed $2,400 among themselves. How much did X get? So these are classic problems, okay? There's X amount divided between 3 or 4 friends. You have to calculate how much each one gets. So statement A, X and Y together get 5/8 of the total amount, and X got the same amount as Z. Statement B, Z got $900 as his share. Using statement A alone, X plus Y got 5/8 share. So what did Z get? 1 minus 5/8, that is 3/8 of the share. X is equal to Z. So Z got 3/8, so X also got 3/8. So what is 3/8 of 2,400? That is 900. So statement A alone is sufficient to calculate how much X got. Using statement B alone, we know that Z got $900, but we don't know how much X or Y individually got, right? So B alone is not enough, but A alone is enough. So we pick option 1. Question 49. What is the speed of the car? So statement A, speed of the car is twice that of the boat in water. Statement B, the water in the lake offers resistance to the boat, reducing its speed by 20%. If the boat was traveling on land or air with negligible air resistance, its speed would be 60 kilometers per hour. So using statement A alone, we don't know the exact speed of the boat or the car. We only know that the car is twice as fast as the boat. Using statement B alone, we can calculate the speed of the boat in water as 80% of 60. So the water in the lake offers resistance to the boat, reducing its speed by 20%. So if the boat was traveling on land, its speed would be 60 kilometers per hour. But if the boat was in water, it's reduced by 20%. So it will be 80% of 60. That's 48 kilometers per hour. So we know the speed of the boat in water, but we wouldn't know the speed of the car using B alone. But using both, we know the speed of the boat is 48 kilometers per hour and the speed of the car is twice of that. So we can calculate the speed of the car. So you need both the statements. So we pick option 3. So question number 50. What is the speed of the bus? Statement A. The speed of the car is 40% more than that of the bus, and the car takes 1 hour less than the bus to reach the destination 50 kilometers away. So speed of the car is 1.4 times the speed of the bus, and the car takes 1 hour less than the bus to reach a destination 50 kilometers away. So if the bus takes t amount of time, car takes t minus 1 hour t number of hours. So a car takes t minus 1 number of hours, bus takes t number of hours, and they reach the destination 50 kilometers away. So clearly, if you substitute c equals 1.4b, so you can solve for t right here, right? We can solve for t, and from that we can calculate the speed of the bus and the speed of the car. So it's clearly statement A alone is sufficient. Let's look at statement B. If the speed of the bus is increased by 20% and that of the car is decreased by 30%, so the speed of the bus will be 5 kilometers per hour greater than that of the car. So speed of the bus increased by 20%. So 1.2b. Car is 30%, 0.7c. then so the difference will be 5 kilometers per hour. So using this alone, it's not sufficient, but A alone is sufficient. So we pick option 1. Question 51. How much does Jack weigh? Statement A. Tom and Peter together weigh 4/3 of Jack. So statement B. Peter is 2/3 of the weight of Tom, who weighs 90 kilos. So using A, Tom plus Peter is 4/3 of Jack. And we can't solve for either of their weight individually. Using statement B alone, Peter is 2/3 of the weight of Tom, and Tom is 90 kilos, so Peter is 60 kilos. So from this we get the weight of Tom and Peter, but we don't know the relationship between their weight to Jack's weight. So using both the statements together, we can solve for Jack's weight. So we pick option 3. We need both the statements to solve this problem. Question 52. X, Y, and Z invested different amounts each as partners in a business for 1 year. At the end of the year, the company went bankrupt. Look how much did X lose? X invested twice the amount that Y invested. Statement B. Z invested 40% of the total amount. So using statement A alone, we cannot X invested twice the amount that Y invested, okay? So X, Y, and Z invested different amounts as partners for 1 year. End of the year, the company went bankrupt. How much did X lose? So X invested twice the amount Y invested. We don't know how much Z invested. So how much did X lose? We can't determine that. Using statement B alone, Z invested 40% of the total amount. So X plus Y invested 60% of it, and then X invested twice of that. So 3Y is 60%, so Y invested 20% and X invested 40% and Z invested 40%. So using both, we still don't know the exact amount. We don't know how much they invested, right? We know the percentages, but we don't know how much amount they invested. So clearly, using both, we still don't know how much loss they suffered. So we pick option 4. Both the statements together are insufficient. So question 53. How are Jack and John related? Statement A. Jack's aunt is the only daughter of her parents, and she has only one nephew. Statement B. John has a son and a daughter, and John's son has only one son. So using A or B alone, let's try. Jack and John, we are trying to find the relationship, right? Jack's aunt, so she could be mother's sister or father's sister. Jack's aunt is the only daughter of her parents, and she has only one nephew. So basically, she's probably like a step aunt or something. She's the only, oh no, she's an aunt. So she's the only daughter of her parents. So basically, Jack's aunt is the only daughter. So she cannot be the mother's sister, right? Because then she would have a sister and the parents would have 2 daughters at least. So Jack's aunt can only be a paternal aunt. She is the father's sister. That's the only possibility, right? So Jack's father's sister, the aunt, is the only daughter of her parents. But clearly they have at least a son who is the father of Jack. So we know she is the paternal aunt. And she is the only daughter of her parents. And she has only one nephew. So Jack is the only nephew. She may have a lot of nieces, we don't know. So, and she might also have other brothers who don't have children. So we don't know that either. So using, we don't even know who John is from this, right? So using statement B alone, John has a son and a daughter, okay? And John's son has only one son. So John's son has only one son, but we don't even know if John's son is Jack. I mean, for all you know, these statements have absolutely no correlation to each other. Like, I mean, so John's son and daughter may be a completely different family. Jack's aunt is maybe a different family. They're not even like related here. So using both the statements together, we still can't say how Jack and John are related. So we pick option 4. Both the statements together are insufficient. Question 54. What is the speed of the boat in still water? Statement A. Downstream speed of the boat is twice the upstream speed. Statement B. The sum of the upstream and downstream speeds of the boat is 18 km per hour. So we know water offers a resistance when you're going upstream, and the flow of the water gives you an incentive when you're flowing downstream. So using statement A, downstream speed is twice the upstream speed, but we still don't know the speed in still water, right? So if the speed of the boat in still water is x, okay, and the resistance is r, so x plus r is twice x minus r. That's what it's trying to say. But you can have multiple values of x and r, so you can't have a unique solution. Using statement B alone, sum of the upstream and downstream speeds is 18 km per hour. So x plus r plus x minus r is 18 km per hour. So the resistance cancels out, and we have 2x is 18, so x is 9 km per hour. So actually using statement B alone, we can solve this problem. See? So I'm sorry, there's a mistake here. So downstream speed is nothing but speed of the boat x plus the speed of the flowing water, x plus r, plus upstream speed is nothing but speed of the boat minus the resistance, x minus r. Yeah, so x plus r plus x minus r. So 2x is equal to 18. So plus r minus r cancels, right? So x equal to 9. So the speed of the boat in still water is 9 km per hour. So using B alone, we can solve it actually. See? So I'm sorry, there's a mistake here. So the option would be 1. You can't solve it using A alone, but you can solve it using B alone. So you'll pick option 1. Okay, I'm sorry, there is a mistake here. I'll fix it later. So data sufficiency question 55. In how many days can 5 men complete a piece of work? Statement A. 3 men and 2 women complete the same work in 8 days. Statement B. 4 men and 3 women complete the work in 15 days. So either statement alone is insufficient, right? So you have like 2 unknowns, right? So but using both together, we calculate the time taken individually by each man and each woman, right? Solving these two, you can find the time taken by each man and each woman, and from that we know the time taken by 1 man to the work, and so from that we calculate the time taken by 5 men. It will be 1/5 of that time. So we pick option 3. So this doesn't take too much time to analyze. You look at it and you know the answer. So question 56. Is x plus y less than 100? Statement A. X and y are 2-digit prime numbers. Statement B. The units digit is 1 more than the tens digits in both numbers. Yeah. Using A. X and y can be 2-digit prime numbers. So what are all the 2-digit prime numbers? 11, 13, 17, 19, 23, 29, 31, and there's 37, sorry, it says 27, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. These are all the 2-digit prime numbers. So x and y are 2 numbers from this set. Using statement B, yeah, x and y can be, like, units digit is 1 more than the tens digits. Using statement B alone, come on, so units digit is 1 more than the tens digits in both the numbers. So the numbers can be 12, 23, 34, 45, 56, 67, 78 or 89. From this set we have to pick 2 numbers. So clearly A and B alone are insufficient, but using both A and B, we can still have the numbers as 23, 67 or 89. So they are prime numbers and the units digit is 1 more than the tens. So it solves, they meet both criteria. So, but we can have three numbers. So x and y can be any of these three. So suppose x and y were 23 and 67. So then x plus y would be less than 100. But 23 plus 89 or 67 plus 89 are both greater than 100. So both statements together are insufficient. So you pick option 4. Question 57. Peter painted the fence in 10 days. Jack takes 6 days to paint the same fence. If Peter, Jack and Tom work together, how long will they take to paint the fence? So statement A, Peter and Tom can paint the fence together in 4 by 9 days. And statement B, the time taken by Tom to paint the fence is the average of the time taken by Peter and Jack. So we know the time taken by Peter, we know the time taken by Jack, and therefore if they're working together, we know how much time they would take, and if the average of their time, that also we know. So if Peter, Jack and Tom work together, how long will they take to paint the fence? So using statement A alone, Peter and Tom can paint the fence together in this much time. So we know how much time Peter takes, and we know how much time Peter and Tom together take. From that we know how much time Tom will alone take, right? So how long will they take if they work together? So we know how much time Peter takes, how much time Tom takes, and how much time Jack takes. Using statement A alone, we can solve this problem. Statement B alone, time taken by Tom to paint the fence is the average of the time taken by Peter and Jack. So we know the time taken by Peter and Jack. The average of that is the time taken by Tom. So Tom takes 8 days to paint the fence. So it's like, we know the time taken by Tom, we know the time taken by Peter and Jack. So either statement alone is enough. So we pick option 2. Question 58. How old is Amy? Statement A, ratio of Bob's age to Carl's age is 3:1. So statement B, Carl is 20 years older than what Amy was 5 years ago. Using statement A, so Bob is 3 times as old as Carl. Using statement B, but A alone is clearly not sufficient to say how old Amy is. Using statement B, Carl is 20 years older than what Amy was 5 years ago. So Amy minus 5 is equal to, Amy minus 5 plus 20 is equal to Carl. So Carl is equal to Amy plus 15. So using both, we still have a relationship between Carl's age and Amy's age, and Bob's age and Amy's age. But we don't know the individual ages of Amy, Bob or Carl. So both the statements together are insufficient. So we pick option 4. 59. What is the unit digit of the 2-digit number x? Statement A, x to the power of 3n ends in 1. Well, x to the power of 3n plus 1 ends in a 9. Statement B, x is a prime number and the sum of the digits is 10. So using statement A alone, the number ends in a 1. There is a particular number ends in a 1. And when the number is multiplied by something, okay? Clearly x is multiplied by itself, right? So x to the power of 3n is number multiplied by x gives this number which ends in a 9. So some number ends in a 1 and you have to multiply it by a multiplier to get a number which ends in a 9. So clearly the multiplier has to be some number that ends in a 9. So clearly the unit digit of that number is 9. So that number, the multiplier is x itself and the last digit is 9. So using this we can solve it. A alone is sufficient. Statement B alone, x is a prime number and the sum of its digits is 10. So how many prime numbers are there? two-digit prime numbers whose sum of digits is 10, 19, 37, 73. So using B alone, we can have three different options. So A alone is sufficient, but B alone is not sufficient. So we pick option 1. Question number 60. If Peter and Jack work for 3 days, each alternately, 3 days each, okay, alternately. So Peter works for 3 days, Jack works for 3 days. And then again Peter works for 3 days. So in how many days can they finish painting the house? So statement A, Peter alone can do that piece of work in 12 days. Jack alone can do the piece of work in 10 days. So clearly, either using A, we know Peter can do 1/12 of the work in 1 day. Alright, so in 3 days he can do 1/4 of the work. So we know how much time how much work he can do per day. And we know how much time how much work Jack can do per day. So Peter and Jack, using both. Okay, so this guy works for 3 days, we know how much work is done. This guy works for 3 days, we know how much time he does. So we can clearly calculate how much time it takes to complete the work. So clearly, both the statements are required. We pick option 3. 61. What is the difference between the product and the sum of the numbers x, y and z? Statement A. X, y and z are consecutive prime numbers. Statement B. X is the smallest of the three numbers and also the largest single digit prime number. So using statement A alone, we cannot determine the numbers. X, y and z are consecutive prime numbers. So they can be like 11, 13 and 17, or they can be 2, 3 and 5. We don't know, right? What is the difference between the product and the sum of these numbers, x, y and z? They're consecutive prime numbers, but we don't know which three. Statement B, x is the smallest of the three numbers and also the largest single digit prime number. So what is the largest single digit prime number? 7. So x is 7, x, y and z are consecutive. So B alone is not enough. But using both, we know x is 7 and the consecutive prime numbers are 7, 11 and 13. So we got the three numbers. So we find the product and the difference between the product and the sum of these numbers. So using both the statements, we can solve this problem. So we need option 3. (62) How many minutes does Ram take to complete the marathon? Statement A. In 4 consecutive years, Ram took a total of 680 minutes to complete 4 marathons. Statement B. Ram increased his speed by 10% each successive year. So using state or B alone, we cannot determine Ram's speed. So in 4 consecutive years, he took total 680 minutes to complete 4 marathons. So we don't know how much time he took each year. For all you know, he might have run really slow one year. We don't know. And using statement B alone, he increased his speed by 10% each successive year. But we don't know what is the total speed, right? So, okay, initially he went at, say, P plus Q plus R plus S. So, but using both statements, okay? Clearly each statement alone is not enough. Using both statements, now let's say P was the speed in the first year, Q is the speed in the second year, R in third year and S in the fourth year. Q is 10% more than P. So Q is 1.1 P, R is 1.1 Q, that is, 1.21 P. S is 1.1 times R, which is 1.331 P. So if you just plug in these values, you get 680. And if you solve for it, you get the value of P, which was the speed in the first year. So we know the speed, how many minutes he took in each of these years. So using both the statements together, we can solve this problem. 63. What is the sum of the 2 digits of the 2-digit number? Statement A. The number is prime and the units digits is a perfect square. Statement B. The tens digits of this number is the largest single digit prime number. Using statement A, the units digit must be either 1 or 9. The number is a prime number and the units digit is a perfect square. So Units digit is 109, and how many prime numbers end in 1 or 9? There could be many, right? So, for example, 29 is a prime number, and say 31 or 11, they're also prime numbers. So it could be any of those numbers. So clearly A alone is not enough. Using statement B alone, tens digit of the number is the largest single digit prime number. So tens digit is 7. But if you, clearly B alone is not enough. But if you combine these two statements, then the number is, tens digit is 7, and it's a prime number which ends in 1 or 9, right? So the number is 71. Yeah, so I'm guessing 79 is not a prime number. I'm not sure about that. Is 79 a prime number? I'm a little confused about that. So I'm really sorry, this is a little embarrassing, but we'll have to look it up. So 77 is clearly not a prime number, but I don't know about 79. So I'm guessing 79 is not a prime number, in which case 71 is the only prime number starting with 7 and ending with either a 7 or a 9, 1 or a 9. And if 71 is the only number that meets this solution, then using both we could arrive at the unique solution and we pick option 3. But if 79 is also a prime number, it also meets both the criteria, then we have two options, and then we will pick option 4, which is both are insufficient. But I guess 79 is not a prime number. I'm sorry, I don't remember it at the top of my head, so you just have to double check. But this is the methodology, how you go about solving these problems. So question 64. Company X made $8,000 profit in the first year. How much profit will X make at the end of the second year? Statement A. Company X made 20% profit by the end of the first year. Statement B. Company X made a profit equal to 10% of the original investment at the end of the second year. Using statement A, 20% of the investment is equal to $8,000. So they made 20% profit. So 20% of the investment was made as profit in the first year. 20% of that is equal to $8,000. So 20% of something. So the amount was $40,000. Investment was $40,000. We can find that out, right? So we don't know how much profit they make at the end of the second year. We don't know if they keep up the same profit percentage, right? Using statement B, company X made a profit equal to 10% of the original investment at the end of the second year. So 40,000, 10% of that is 4,000. So in the second year they made 4,000 profit. So we know the investment from statement A, and from that we know 10% and we calculate that. So we need both the statements together to calculate the profit at the end of the second year. So we pick option 3. Question 65. What is the principal amount invested to earn compound interest? So statement A, the amount is invested for 5 years. Statement B, the interest earned is 470. So we need to know the rate of interest, duration, and the interest earned in order to determine the fourth component, which is the principal invested. Yeah. So different principal amounts at different rates of interest can give same interest over time. We do not know the rate, so both statements are insufficient. So the interest earned is this much, and we know the duration. We don't know the principal and we don't know the rate of interest. For example, amount X invested for 5 years at Y% interest can give interest 470, and a different amount P invested for 5 years at a different rate of interest Q can also give interest 470. So the principal and rate can vary, and they can still give the same amount of interest in 5 years. So we don't know. There's no unique solution using both these statements. So we pick option 4. Both the statements together are insufficient. Question 66. What is the average speed of the bus over the entire distance? Statement A. The bus could cover the same distance in 20 minutes less time if it increased its speed by 30 kilometers per hour. Statement B. The bus starts with a speed of 20 kilometers per hour and increases its speed by 5 kilometers per hour each time after covering 20% of the total distance till it reaches the destination. Using A, we cannot find the exact speed of the bus. The bus could cover the same distance in 20 minutes less time if it increased the speed by 30 kilometers per hour. So at a speed of x kilometers per hour, it took y amount of time to reach the distance. So x times x, speed of x and y time, so xy equal to distance, and x minus 20. So say x will increase by 30 kilometers per hour. So x plus 30 and y minus 20 minutes is nothing but 1/3 of an hour. Y minus 1 by 3. So x plus 30 times y minus 3 is equal to xy. But that doesn't solve uniquely for x and y because we don't know the total distance covered. So if it said the bus could cover the same distance of 100 kilometers in this 20 minutes less if it increased by 3. If we know the distance, then we can solve for the speed and the time. But we don't know the distance, so from statement A alone we cannot solve the problem. Using statement B alone, starts with 20 kilometers per hour, increases its speed by 5 kilometers per hour each time, every 20%. So 5 times it increases its speed. So first it's 20, and after 5 kilometers it increases it to 25, and after another 5 kilometers it increases to 30. So 20, 25, 30, 35, 40. So it increases till it reaches destination. So we don't have to know the total distance, okay? Let's say the total distance is say 5d, okay? So after 1/5 of that, after covering d, the speed becomes 25. First it's like 20, and then it becomes 25, then it becomes 35. So if you see what was the average speed, so it's like it's 20 kilometers per hour for a distance d, okay? So we just need to calculate the average speed of the bus, right? So what is the average speed? Is like total distance divided by total time. So the distance can be written as so this is the continuation in the next slide. So we'll divide the total distance into 5 parts and say time taken to cover the last part is x hours, okay? Then we get the total distance in terms of x for the 5 parts added together, and we can add the total time for each of the 5 parts in terms of x. Total distance divided by total time is average speed. So 20, and what is the 20 kilometers per hour, and what is the time taken is the distance, right? So let's say, for example, distance into 5 parts. Time taken to cover the last part is x hours. Okay, so the total distance is covered into 5 parts. Last part is covered at a speed of say 40 kilometers per hour, right? So we have 20, the last segment, okay, the time taken to cover that is x hours, and at a speed of 40 kilometers per hour, it's going for x hours, okay? That's the time taken to cover the last 5th part of the segment. And the 4th part will be, the speed was 35 kilometers per hour, and what is the time taken? It will be 40x divided by 35. It takes slightly more time because it's at the lower speed, right, to cover the same distance. The distance of this segment is the same as the distance of this segment, so there's 5 segments. At 40 kilometers per hour, it takes X amount of time. 35 kilometers per hour, it takes 40 by 35 times X amount of time. And before that, the speed was 30, so it will be 40x divided by 30. And then before that, the speed was 25, 40x by 25. 20 times, so 40x by 20. So if you add up all these things, it gives total speed into time, so the distance. So distance divided into 5, that will give the total distance, right? So if you add this all up, the total distance is nothing but 5 times 40x. And total time will be 40x by 20 plus 40x by 25, 40x by 30, 40x by 35, and x number of hours, right? So total distance and total time. So if you just add this, you get 89x by 15. Total distance divided by total time is nothing but the average speed. That's, so basically this is 200x, so divided by 89x by 15. So 200 times 15 divided by 89. So this will give you the value of the average speed. So you got the concept, right? Divide the distance into 5 chunks. The last chunk, it was traveling at 40 kilometers per hour. Let's say the time taken to do that is x. And then substitute all these times taken to do it at different speeds in terms of x. Okay, all you need is like the total distance divided by total time. That will give you the average speed. So my point is, using statement B alone, we can solve for the average speed of the bus. But using A, we can't. So we pick option 1. Question 67. What is the cost of the book? Cost of the, statement A, cost of the book is equal to the total number of pens. Statement B, total cost of all the pens and the book is 4 times the cost of the book. So remember, we have to find the cost of the book. So let's say N is the number of pens, each costing P rupees. Okay, B is the cost of the book. There's only one book. So using statement A, B is equal to N. Cost of the book is equal to number of pens, N. Using B, number of pens times cost of the pens plus the cost of the book is the total cost of all the items. Okay? Total cost of pens plus the book is equal to 4 times the cost of the book, 4B. So solving this, you just take the B on the other side. So NP equals 3B. So we get that. So either statement alone is not enough, but using both the statements. So B is equal to N, right? So instead of B, I put N. So we get P equal to 3. So pens cost 3 rupees each. So we can only solve for the cost of the pen, that is 3 rupees each. But can we solve for the number of pens? 3n plus, so 3n equals 3b, the cost of the book. So n is equal to b, but then what is the relationship between b and p, or n and p? We don't know. So my point is, we could calculate the cost of the pen, but we don't know the cost of the book. And we don't know the number of pens either. We can't solve for N or P. We can only solve for B using all this information given. So both the statements together, however you try to solve it, you can't solve for the number of pens. We can only solve for the price of the pen. We couldn't find the cost of the book. So both statements together are insufficient. It's kind of tricky. It looks like you can solve it, but you really can't. It's a kind of tricky one. You can waste all your time trying to solve it, but at least I couldn't. So both the statements together are insufficient. So question number 68. How fast can Jim swim in the still waters of a lake? Jim covers downstream a distance of 14 kilometers in 2 hours. Statement B. Jim takes 4 hours to cover the 14 kilometers swimming upstream. So downstream 14 kilometers 2 hours and upstream 14 kilometers 4 hours. Flowing water offers resistance of r kilometers per hour when Jim swims upstream and adds a benefit of r kilometers per hour when Jim swims downstream. Jim's speed in still water is x kilometers per hour. So using statement A. So his downstream speed is 7 kilometers per hour, right? X plus r is 7. And upstream is 14 by 4, that is 3.5. So x minus r minus the resistance is 3.5. So if you solve these two together, it's 2x is 10.5, and so x is half of 10.5, which is 5.75. No, 5.25. So using statement A alone, you can't solve it. And using statement B alone, you can't solve it. But using both together, you solve for x. So option 3, both the statements are required. Question 69. The average age of P, Q, R and S is 42 years. How old is Q? Statement A. The sum of ages of P and S is 54 years. Statement B. Q is twice as old as R and 2/3 as old as P. Using statement A alone, P plus S is 54 years. So I'm sorry, it says 56, it should be 54. 54 plus Q plus R divided by 4 is 42. So the average age of the 4 is 42, right? So we know the two of them average is 54. So 54 plus Q plus R divided by 4 is 42. So we get Q plus R is, you take the 4 on the other side, you get 168 minus 54. So you get Q plus R is 114. So we know P plus S is 54, Q plus R is 114. Using B, Q is equal to 2R and Q is 2/3 of P. So I'm putting P, Q and R in terms of Q, okay? So P, I'm putting it as 3Q by 2. Q is Q and R is Q by 2, okay, plus S. So we get the relationship, take the average divided by 4 is 42. So 3Q plus S is 168. So we know the relationship between P plus R is something, Q. So B alone is not sufficient, okay, to solve for Q. But using both, now substitute R as Q by 2 in the first equation, okay. We know that Q equal to 2R, right? Using both. So we know Q plus R is 114 and Q is equal to 2R. So R is Q by 2. So Q plus Q by 2 is 114. 3Q by 2 is 114 and you solve for Q, you get Q. So using both, we can solve for the age of Q. But using either statement alone, we cannot solve it. So we pick option 3. What is the normal speed of the bus? Statement A. The speed of the bus is increased by 20 kilometers per hour to reach a village 100 kilometers away on time. Statement B. The bus is late by 20 minutes. Using statement A. At a speed of s kilometers per hour, the bus takes x hours to reach 100 kilometers. Speed is s and time taken is x number of hours. S times x is 100 kilometers on time. And speed of s is increased by 20 kilometers per hour to reach a village 100 kilometers away. So s plus 20 So basically, s is the speed, the increased speed, okay? And it takes x hours to reach 100 kilometers on time. So S is the increased speed, let's say, for example. So anyway, using A alone, you can't solve for the speed of the bus. That's the material point. Using B alone, bus is late by 20 minutes. So at a speed of S, the bus was late by 20 minutes. Okay. So they had to increase the speed of the bus by 20 kilometers per hour to make it reach, to reduce the time taken by 20 minutes. So they had to take it as, increase the speed S plus 20 kilometers per hour, and then 20 minutes is nothing but 0.3 hours. Then it would take 20 minutes lesser to reach 100 kilometers. So using both, you substitute them and we can solve the problem. So option 3. So question number 71. How many students are there in the class? Statement A. Average age of the students in the class is 16 years and their age ranges between 14 and 18 years. So clearly, using statement A alone, we don't know how many students are in the class. Their age ranges between 14 and 18 and average is 16 years. But we don't know the number of students in the class, clearly. So B, statement B, the total age of all the students in the class and the teacher is 256 years. So the teacher is twice as old as the average age of the students. Using statement B, suppose there are n students in the class and the average age of the students is x. Teacher is twice as old as the average age, 2x. So nx plus 2x is 256, where x is the average age of the n number of students. So x times n plus 2 is 256. And there's no unique solution. But using both statements together, average age of the class is 16 years. So x is 16 and 16 times n plus 2 is 256. So n is 14. So we know the number of students in the class. So using both the statements together, we can solve for the number of students as 14. So we have 3. But either statement alone is not sufficient. The sum of the ages of 5 friends is 290 years. How old is Tom? Statement A. The average age of Tom's 4 friends is 64. Statement B. Tom is the youngest in the group. So using A, we can calculate Tom's age. So the average age of Tom's 4 friends is 64. So P plus Q plus R plus S. So P, Q, R and S are Tom's 4 friends. So P plus Q plus R plus S divided by 4 is 64. So P plus Q plus R plus X is 256. And therefore, if Tom is the 5th one, the sum of the 5 ages is 290, right? So 290 minus 256 is 34. So Tom is 34 years old. So using statement A alone, we can solve for Tom's age. Using statement B alone, Tom is the youngest in the group. That doesn't tell us anything. So A alone is sufficient, and so we pick option 1. 73. So what is the difference between the 2 digits of a 2-digit number? Statement A. The number is a multiple of 11. Statement B. 1/5 of the number is the smallest 2-digit prime number. So using statement A alone, all 2-digit multiples of 11 are 22, 33, 44, 55, 66, 77, 88, 89. They all have the same digit in the unit and tens place. Number is a multiple of 11 and it's 2 digits, right? So if you see any of these multiples of 11 which are 2 digit, they all have the same digits in the unit and tens place. So the difference between the digits will be 0, right? Regardless of which number you pick. So using A, the answer is, we can solve this problem. The difference in the digits is 0. Using B, 1/5 of the number is the smallest 2-digit prime number. So 1/5 of the number, so 1/5 of x is the smallest 2-digit prime number. The smallest 2-digit prime number is 11, right? So x by 5 is 11. So x is 11 times 5 is 55. So in this case, we've solved for the number as 55, and the difference between the 2 digits is 0. And in the case of A, we pick any of these numbers, the difference in digits is anyway 0. So either way, each statement alone is sufficient. So we pick option 2. Question 74. There are two integers x and y. Is any of them an even number? Statement A. The product of the two numbers is twice their sum. Statement B. The sum of and difference between the numbers is even. Using A. So x and y are integers. Is any of them an even number? That's all we have to find out. We don't have to solve for the number. Product of the two numbers is twice their sum. X times y is 2 times x plus y. So if x and y are both odd numbers, the product will be an odd number, right? But it's 2 times something. So xy is clearly an even number, right? Because it's 2 times x plus y. So as x of xy is even, so either x is even or y is even. One of the two is even. So is any of them an even number? One of the two must be an even number to satisfy this criteria. So using statement A alone, we can say at least one of them must be even. Using statement B alone, the sum of and difference between the numbers is even. We don't know if either number is even. So sum of the two numbers, let's say they are two odd numbers like 3 and 5 for example. Say 5 and 3. 5 plus 3 is an even number and 5 minus 3 is an even number. But both of them are odd, right? So if they're like say 2 and 4. So 2 plus 4 is an even number, say, and 4 minus 2 is an even number. So we don't know if the numbers are both odd or both even. So statement B alone is not sufficient, but statement A alone is sufficient. So we pick option 1. So question 75. The product of the ages of P, Q and R is 108 years. What is the age of Q? Statement A. P is 3 times as old as R. Statement B. The total ages of Q and R is 7 years. Using statement A, P equal to 3R. So therefore, 3 times PQR is 108, right? So 3QR square. So instead of P, I put 3R. So 3QR square is 108. So QR square is 36. So using B, the total age of Q and R is 7 years. So Q plus R is 7. So either statement alone is not enough, but using both together, we can solve for P, Q and R. So in this equation, QR square is 36. Put Q as 7 minus R. So 7 minus R times R square is 36. You get a quadratic equation in R. Solve for it. It's not a quadratic equation actually. Yeah, it's a kind of, you just plug in some values. I mean, so Q R square is 36, right? So what can R square be? It can either be 4 or 9 or 16, right? Even if you had R square is 16, you can't multiply it by an integer to get 36, right? If R square is 9, then Q is 4, you get 36. If R square is 4, Q is 9 is 36. R square is 9, Q is 4, 36. So R square can be either like 9 or 4. And if we know that Q plus R is 7, so we solve for P, Q and R. And we know that P is 3 times as old as R. So we uniquely get P as 9, R as 3 and Q as 4. So PQR 9, 4 and 3 years old. So Q is 4 years old. So using both the statements together, we can solve for the age of Q, but not using either statement alone. Question 76. A shopkeeper has 2 types of beans of the same size, but different quality. Okay, so 2 types, X and Y. Bean X costs $30 per pail, and bean Y costs $20 per pail. He mixed the 2 types of beans and sold the mixture in pails. What is his profit amount? Statement A. He sold the mixture at a rate of $24 per pail. Yeah, but we don't know how many pails of X type of beans he used and how many pails of Y types of beans he used. He mixed them, but we don't know in what ratio. We don't know whether he had an equal quantity of both, right? we don't know how many pails of x and how many times pails of y he had, right? So, and statement B, he had twice the quantity of bean y as bean x. So using statement A, if he sold x pails of bean x and y pails of bean capital Y, cost price would be 30x plus 20y, and the selling price would be 24 times x plus y. So he mixed x plus y together and sold them at 24. So what is the profit amount? So that would be 24 times x plus y minus 30x minus 20y, right? So the difference between selling price and cost price would be the profit. And statement B, he had twice the quantity of bean y as bx. So y is equal to 2x. Total cost price is, so 30x plus 20 times 2x. So 30x plus 40x is 70x. So cost price was total 70x, and the selling price would be 24 times 3x, that will be 72x. So selling price is 72x and cost price is 70x. So the profit is 2x. So what is the profit amount? We don't know x or y, right? So we don't know the exact profit amount. If they are asked for the profit percentage, so we know the profit amount is 2x and the cost price is 70x. So profit percentage would be 2x divided by 70x times 100. So that would be 100 by 35. That would be the profit percentage. But they want to know the profit amount, that is 2x. We don't know the value of x or y. So we can't solve for the profit amount. So both the statements together are insufficient. We pick option 4. Question 77. What is the area of the square? Statement A. The area of the circle circumscribing the square is 2 times the area of the larger circle inscribed in the square. And statement B. The area of a regular hexagon of the same length of sides as the square is 50 square centimeters more than the area of the square. Using A, we know the ratio of the diagonal of the square to its side. So there is a square and there is a circle circumscribing it and the circle inscribing it. The radius of the circle circumscribing it is the diagonal, half of the diagonal of the square. And the radius of the the circle inscribed in it is the half of the side of the square. So I mean, using this equation, I mean, area of this bigger circle will be pi r square, right? Pi times, where r is like the diagonal by 2, right? And diagonal is nothing but square root of times the side. So it's nothing but if the side of the square is r, the diagonal is root 2 times r, and half of that is r divided by root 2. So pi times r by root 2 the whole square is equal to the area of the bigger circle. So that's nothing but pi r square by 2. And then we know the area of the circle inside. So that's nothing but the radius of that circle is r by 2. So that will be, the area of that circle will be pi r square by 4. So pi r square by 2 minus pi r square by 4 is nothing but, so pi r square by 4. So we know the difference in the areas between these two. And my point is, we know the area of the bigger thing and we know the area of the inner circle, and regardless of what the dimensions of the square are, the area of the circle circumscribing is always 2 times the area of the circle inside, usually. So I'm saying that doesn't tell us we can't solve for r using that. We can't solve for the length of the side of the square or the diagonal of the square. Using statement B, if area of a regular hexagon of the same length of sides as the square is 50 square centimeter more than the area of the square. Side is x centimeter. 6 times so the side of the hexagon is x centimeter. So hexagon is nothing but regular hexagon. So it's 6 equilateral triangles, right? And what is the area of the equilateral triangle? Root 3 x squared by 4, right? So 6 times of that. So that is nothing but the area of the hexagon is equal to area of the square, x squared plus 50. Solve for x. So using this we can clearly solve for x. So B alone is enough. Using statement B alone we can solve for the area of the square, but not using A alone. So pick option 1. Question 78. A postman delivers letters from village P to village Q, either by bicycle or by car. Is Q more than 200 kilometers away from P? So is the distance between P and Q more than 200 kilometers is what they're asking. Statement A. When the postman travels by car, he can leave P at 10 a.m. and reach Q by noon. So statement B. The car travels 25 kilometers per hour faster than the bicycle and takes 30 minutes less than the bicycle to reach village Q. So using statement B alone, okay? If B is the speed of the bicycle, x is the time taken. So Bx is the time taken to travel the distance to Q. And so car takes 25 kilometers more. So B plus 25 takes 30 minutes less, x minus 0.5. So if you increase the speed by 25, decrease the time by 0.5 hours, you multiply them and you still get the same distance, PQ. So using A, when the postman travels at a car speed B plus 25, maximum time taken is 2 hours. So when he travels by car, he leaves at 10 a.m., reaches by noon. So he takes 2 hours. So at the speed of B plus 25, he takes 2 hours. So plug that into this equation from B, okay? So using A alone or B alone, we cannot solve it. But using both, we get 2B equals B plus 25 times 1.5. So solving, you get P is less than or equal to 150 kilometers. And so we can answer the question. It's not more than 200 kilometers. So we need both the statements to answer this question. Just plug it in here and you'll solve it and you'll get it. So my point is we can't solve it using either one, but you can use both the statements together to solve this question. So we pick option 3. Question 79. What is Mary's current age? Statement A. When Jane celebrated her centenary birthday, Mary was eagerly waiting to celebrate her own centenary the next year. Statement B. Jane died at the age of 105 in her sleep. So using statement A alone, Jane was 100, Mary was 99, waiting to celebrate her 100th birthday. But we don't know in which year that was, right? So for all you know, it might have been 20 years ago. So Jane may be now 120 or maybe 110 or 102. We don't know. We don't know how many years ago that was. So we can't solve for their current age. Statement B alone. Jane died at the age of 105 in her sleep. So we don't know in which year Jane died. So we don't know if Mary is now 102 or 105 or any number of years old. I mean, we don't know. So Jane died at 105. So when Jane died at 105, Mary was 104. But now Mary might be 109. We don't know, right? So both the statements together are insufficient. So we pick option 4. So this is the last question, question 80. Two pipes A and B differ in diameter and flow into a tank T. So you're going to expect some questions like pipes flowing into tank and they fill the tank at different rates and stuff like that. In how many hours can pipe A fill the tank? Pipe A and B differ in diameter and flow into tank T. Statement A. Pipes A and B together can fill the tank in 5 hours. Statement B. Pipe A alone can fill the tank of twice the volume of T in 12 hours. A and B together fill the tank in 5 hours. Using A alone, we cannot determine the individual rate of either pipe. Pipe A alone can fill a tank of twice the volume of T in 12 hours. So to fill the volume of T, it will take half of that time, right? 6 hours. So using B alone, we can say how much time pipe A will take to fill a tank of volume T. So option 1. So statement B alone is sufficient, but not statement A alone. So we pick option 1. So this brings us to the end of this video about data sufficiency questions, and I hope I've helped you to try and analyze the tactics and how to solve such questions. So this is a really important component of any GRE GMAT exam, and it's also useful for CAT, like if you're preparing for CAT for MBA entrance exams in India. So wish you good luck, and I hope you found this useful. The trick is to practice a lot of data sufficiency questions. So thank you very much.